Welcome to Okonkwo Academy. In this tutorial, I'll be taking you guys through point sets. And under point set, I'll be taking you guys through open and closed interval, bounded and unbounded intervals, and also neighborhood of a point or a midpoint. If you are new to this channel, I recommend that you please subscribe and put us on post notification so that you'll be notified whenever we upload a video. Now, suppose we have 2 points A and B, two real numbers A and B. An open interval of this numbers can be written as A is less than X, which is less than B, or open brackets A, comma B. This means that interval does not contain the boundaries of the interval. So the interval does not contain A and B, but contains points within A and B. So let's take an example. Let's say we have 2 is less than X is less than 5. Now, please note that we are dealing with discrete intervals here. We have two intervals. We can talk about discrete and continuous interval. For discrete interval, we deal with only whole numbers. But for continuous interval, we deal with decimals and also whole numbers. But we want to focus on discrete intervals here. So when I ask you to write the interval for this, because this is an open interval, we do not include the endpoint. So this is called lower bound and this is called upper bound. We do not include this. So we write this as 3, 4. This is the interval. So 3, 4. Now, when we talk about closed interval includes the endpoint, that is the boundaries. It includes the lower and upper boundaries. So for that one, using the same example, we write it as 2 is less than or equal to X, which is less than or equal to 5. So for this, it includes 2 and 5. And so when we are writing it, we write it as 2, 3, 4, 5. So for closed intervals, we include the lower and upper bounds, but for open, we do not include the lower and upper bounds. Now we come to bounded intervals. For bounded interval, we have something we call half open and half closed. I've told you that when you hear open, it means that it does not include that bound, either the lower or upper bound. But if you hear closed, it includes that bound that we are talking about. So if I say for bounded, we have something we call left closed and right open. So let's say this is the interval. I write the interval as, also I forgot to talk about this. For closed intervals, we write it as a square bracket 2, 5. A square bracket. So if you see a square bracket, it represents a closed interval. So let's now talk about the left closed and right open. Then right open. So for left closed, so using the same AB, so left closed, right open. I can write this as left closed, so is equal to X, which is less than B. So with this, it means that it contains the lower bound but does not contain the upper bound, right? So let's take an example. The same example, 2 is less than or equal to X, which is less than 5. So please write the answer for this in the comment section, or you can pause this video and write it. So it is going to be 2, 3, 4. It does not include 5 because 5 is open, right? 5 is open. We also have left open, right closed. So left open, right closed. So for this, we say A is less than X, which is less than or equal to B. So for this, A is not included when we are writing the interval, but B is included. Also, we have what we call unbounded interval. Unbounded interval. So for unbounded interval, one of the boundaries is specified. Only one is specified, and it goes to the end. It does not end. So it ends at either negative infinity or positive infinity. So we have what we call the right open interval or right closed interval, or left open interval, left closed interval. So if you let's take an example. Say we have x is less than a. First of all, we should know that this will be an open interval because it does not include the boundary that we are specifying, right? So because this takes into account only one interval, so only one bound, it is an unbounded interval. Now let's represent this on a number line. Let's represent this on a number line. Sorry. Let's represent this on a number line. So let's say this point is E. Now look at where the arrow is moving. The arrow is moving to this portion. So it means that this interval is from A to negative infinity. So it is from A to negative infinity, right? So I can write this as negative infinity, comma, A. So because it is an open interval, I use a normal bracket. So it does not include A. So it includes all points from A to negative infinity. So let's use let's use an example. So x is less than, let's say, 3. I'm saying we are considering discrete intervals. So we write our intervals in terms of whole numbers. So we will have 3, 2, 1, 0. Then we'll go out to negative. So we'll go to negative infinity, right? So this 0 to negative infinity. So this is how we go about the intervals. So I'll leave it to you to do for x is less than or equal to a. So this will be a closed, right? A closed right interval. A closed right interval, or right closed interval, anyhow you put it. So I'll leave it to you to do that, and also do for an open left interval and a closed left interval. You can also put your answers in the comment section for me to look at it. Now we'll deal with the midpoint of an interval. Let's move on to the midpoint of an interval. So suppose we have a real number a and b on a number line. So let's write here a and this point as b. Let's say we locate a point between these two real numbers. We divide these real numbers into two. Let's name that C. We can find C by adding A and B and dividing it by 2. So C will be equal to A plus B divided by 2, because C divides A and B into 2, right? And we call that the midpoint of A and B. Then the distance from C, that is the midpoint of A and B, to either B or A is called the radius of that interval. So A and B forms an interval. We have a midpoint which is C in between them, and the distance from the midpoint to either A or B is called the radius. It will be equal because C divides A and B into 2, and so the distance from here to C should be equal to the distance from C to B, right? And we name that delta. Let's name that delta, and delta is the radius of the interval, right? And the radius of the interval, which is delta, can be found as A minus B divided by 2. Okay, so we will be using this very much to find neighborhood of a midpoint. We will be using this to find neighborhood of a midpoint. Yes, but first of all, before we get to that, I would want us to know something small about absolute values. Absolute values. So let's say I have -2. The absolute value of -2, which is represented by 2 bars, right, will be equal to +2. So the absolute value of a number is the non-negative number, right, of that same number. Yes. So absolute value of -2 is 2. So let's say I have an equation which is x minus 6, right, is equal to 2. I'm asked to find the value of x, right? So what I do is that I find the value of x when this 2 is equal to is a +2, and the value of x when this 2 is a -2, right? Because before I place the absolute there, I don't know whether that 2 was a negative or a positive, right? And so x would have two solutions: a point where the 2 is positive and a point where the 2 is negative. Because absolute is found, you see, for this portion, when we were finding the absolute, it was negative, but the absolute made it positive. Yes. So if I want to find the value of x, I say x minus 6 is equal to plus or minus 2, right? So I'll take one. I'll say x minus 6 is equal to, first of all, +2. Then x will be equal to what? 8. Then I'll do same. I'll say x minus 6 is equal to -2. Then I'll say x is equal to what? 4. Right. Good. So I have two solutions that makes this equation true. So when I put 8 in this equation, I get 2. Absolute value of 2 is what? 2. When I put 4 in this equation, I get -2. Absolute value of -2 is what? 2. Yes, that's how it's done. So now let's do absolute values of inequalities. So let's say I have x, the same thing, x minus 6 is less than 2, right? So for this, I'll say x minus 6 is less than plus or minus what? 2, right? Yes. Then because we have minus and plus, I can write this. This one has many ways of solving it, right? So because it's plus or minus, I can write this as x minus 6, x minus 6 2, then so I can write it like this, right? Yes. So if I'm writing it like this, whatever I do to the left hand side, I need to do same to the right hand side, right? So first of all, I need to remove this portion. So for me to remove this portion, I add 6 to each side, right? I add 6 to each side. I add 6 to each side to remove the 6 from this portion, right? So I add 6 to each side. Then I get 4 here, x less than 8. So this is what we get for the interval when we are using inequalities, right? So now we move to neighborhood. So if I'm giving, if before we get to neighborhood, we need to treat another concept where when we are giving the midpoint and the radius of a particular interval, we can find the interval. So let's say the midpoint, as we know, we made it C, so the midpoint is C, right? And the radius of that interval is delta. Sometimes you are given the midpoint and the radius and we are asked to find the interval that give us this midpoint, right? So we can write it in this form. We can write it in this form. It's either we use this to solve for simultaneous equations to get the value of a and b and write the interval, or we use this formula. So when we are given the midpoint and the radius, we can write it as this form: the absolute value of x minus the radius is less than or equal to, depending on whether the the interval is closed or open. So here I'm assuming that the interval is closed, right? So x minus c absolute of that is less than or equal to the radius. So this is going to give you the interval that we had the midpoint and the radius from. So solving this, we are going to get x is less than or equal to c plus the radius. Then the lower bound, we are going to get c minus the radius. So this will give us the a, and this will give us the b. This will give us the b. So it's this concept that we take to neighborhood of a midpoint. So for neighborhood, they will tell you to find the delta neighborhood. I'm going to shorten it, neighborhood of maybe C. So the midpoint. You see, maybe they'll say find 3 neighborhood of 2. So it means that they've given you the radius to be 3 and the midpoint to be 2. So let's do an example. 3 neighborhood of 2. 3 neighborhood of 2. So this means that they've given you the radius and this is the midpoint. So for me to get the interval, for me to get the neighborhood of the midpoint, it is just that I'm going to get a range of numbers around the midpoint, right? That satisfies that equation. So 2 is the midpoint, 3 is the radius from the midpoint to the boundaries, right? Yes, I've already explained that. So for me to get the interval, I use the same formula. So the interval will be 2 minus 3 is less than or equal to x is less than or equal to 3 plus 2, right? So I get -1 is less than or equal to x, which is less than or equal to what? 5. So for this 3 is the delta, 2 is the c, right? Thank you very much for watching this video to the end. Do well to like, comment and subscribe, and share this video to your friends who have difficulty in point set. Thank you.